All right. Good morning or good right afternoon for Sunday, June 9, 12:04 p.m. Yeah, it could be good afternoon. So I hope everybody's doing fine. Good news is we're halfway through. Bad news is test 2 is the hardest one. So put all your effort in it. And every bit of chapter 4, chapter 5, and chapter 6 are equally important. So last week's video was about important points of chapter 4. So in this video, I would I'm going to try to show you what is important bullet points that you really need to know from chapter 5 and chapter 6. So first of all, let's go ahead and get started with chapter 5. All right. So we need to know what's discrete, what's the continuous random variable. We should be able to define a probability distribution. Right? Probability distribution could be about discrete or continuous random variable, but the variables should have numerical values. Right? So that's one important thing. So how can we decide about the valid distribution? So the probabilities of random variables should be, each probability should be between 0 and 1. They could be discrete or they could be continuous. When you add up the probabilities, they should add up to 1 also. And also there is a thing called finding discrete or continuous random variable expected value. So how would you find the expected value of a random variable, discrete random variable? Right? Because expected value is equal to mean actually. But when you talk about the discrete random variable, there's a certain formula for that. Binomial distribution, that's the other important thing in chapter 5. What qualifies a distribution as a binomial distribution? There are 4 conditions for that. Right, so you really need to know those. So they are either 0 or 1, or they could be either success or failure, or they could be either having a Twitter account or not having a Twitter account, being a universal donor blood type, or not being a universal donor blood type. So to be or not to be, that's binomial distribution, condition 1. There is a certain way to calculate the binomial distribution mean and standard deviation. Know those formulas. So I jumped in all over the places. So you need to have equal number of success for the binomial distribution. That's condition 2. You need to have fixed number of trials and equals to something. Each time your success or failure should be able to identify. You really need to be able to identify what is the random variable in binomial conditions. So 4 conditions, 2 parameters. Okay, we really need to know the conditions of binomial distribution. And binomial is a special case of normal distribution. Normal distribution is the umbrella. Binomial is a special case. There are other discrete probability distributions, like geometric one, but we're not interested in with that. Okay, so this is all about chapter 5. And this was about your assignment also, which is due on Wednesday. Now, chapter 6 is about normal distribution. So properties and parameters. What are the normal distribution properties? What are the parameters of the distribution, mean and standard deviation? Finding the probability, right? And we're going to use Excel, not the tables. That's important. That's an archaic way. We're not doing it. And we should also be able to identify the inverse probability. So before I go into sampling distribution, all right, I just want to show you something about the normal distribution formulas. So if you do have a normal distribution, hence one thing, I'm assuming that all this are going into your 4x6 note card or cheat card. So when you use these formulas, when it starts with equal norm.dist or 1 minus norm.dist or norm.dist for the two intervals, what we are finding, they're giving us a value and we're finding the percentage, which means that that is area under the curve. Okay, when you're finding a probability, you're finding a percentage, and probability, percentage, and area under the curve are the consistent or coherent things that you're doing. So we might be finding a probability of less than a value, which is the case here, and this will be the formula that we're going to use in the Excel or comment, Excel comment. If you're finding a probability of a greater than a value, and this will be the area, and this will be the Excel comment that we're going to use. And if you're finding a probability between two values, this is the area, must be drawn, and this is the long formula. With this long formula, I suggest, look, you're starting B, because B hence is the greater value, and then you're subtracting that area. Again, all this brownish looking formulas are valid when you're trying to find a probability of a certain value, which is area under the curve. However, there's a puppy example on the PowerPoint slides, and all those, meanwhile, are coming from 6.2 PowerPoint slides. I don't remember the slide numbers though. You might want to go ahead and check it. So remember the puppy example. We do have a puppy weights curve with the mean given, standard deviation given. What is the puppy weight? That marks the bottom 5%. So first put the shape down, right? 5%. Now the area is given, so what value do we need to put there? Now for that, now we're using norm.inverse formula. Okay, so percentage comes first, and then mu, and then standard deviation, which is coming from here. Okay, so then 8.53 is the A value that we are going to be seeing there. Okay, so I just wanted to make that distinction between those two formulas. If you're using norm.inverse, you have the area, you know the probability. Okay, now what do you need to find out? That value, a single value. Okay, that probability area is a single value also, but it's the whole shaded part that we're trying to find here. The probability is the shaded part. Okay, here the value is that purple dot point. So that's about the normal distribution formulas. The second thing is the most important thing, one of the most important things in this course, CLT, central limit theorem. All right, so central limit theorem happens under either or two conditions. You need to remember that. Either your population has a histogram approximately a normal shape, or you do have a sample size greater than 30. So your histogram might not have an approximately normal shape, skewed population histogram, then your sample size must be greater than 30. If you do have a smaller sample size, look back to your histogram. If it is approximately normal, which means that you can read it from the histogram, or you can check mean and median values if they're close to each other, that means that population distribution is approximately normal. So we can have a sample size less than 30. CLT theorem is applicable. Okay, so check that two conditions. I'm underlying it. Meaning of the two conditions is important. It's either or. Okay, and how do we use the central limit theorem? So central limit theorem says that population mean is equal to sampling distribution mean. All right, and then population standard deviation will be equal to standard deviation over square root of it. All right, so I have prepared PowerPoint slides for test 2 review materials and test 2 extra reviews, I guess we have so many test 2 reviews there. If we go ahead and have a look, yeah, there's a text summary there for test review slide, test review key, lab manual problems, unit 2 extra practice. These are all good resources for your test review. Let me know if you have questions and concerns, and remember that your MyStatLab quiz 6 due by tonight midnight, and I hope that you guys already start going with the binomial exam. Alright, that's all from me. Enjoy rest of your weekend, whatever is left, and don't forget the due dates. Bye.